How are you doing, everybody? This is Dr. Nandi. I'm back again with an integral calculus problem, part two of that problem. Continuation of part one, basically. So I'll share my screen with you. An object is dropped from a height of 400 feet. If the air resistance is proportional to the square of the velocity, then dv by dt is equal to minus 32 plus kv square. Okay. Where minus 32 feet per second square is the acceleration due to gravity and t is a constant. Show that the velocity as a function of time t is is minus then square root of 32 over k tangent of hyperbolic inside the parenthesis square root of 32 k outside the square root is t. Use the result of part A to find velocity as a function of time and with the limit t approaching infinity. So first we will do dv over dt is equal to minus 32 plus kv square. Integrate with, we separate the terms actually. We take dv divided by minus 32 plus kv square on the left hand side. On the right hand side we transfer the dt and then we integrate on both sides. So integration of dv divided by 32 minus kv square is minus dt. Let u is equal to square root of kv and then du is square root of k dv, or dv is equal to 1 over square root of k multiplied by du. So basically I'm dividing by square root of k on both sides and I get du or dv is equal to 1 over square root of k du, or substituting for u, okay, we get, okay, so we are replacing dv with u, so we get 1 over square root of k du 32 minus u square on the right hand side of the equal to sign minus integration dt, and this comes with a standard formula. The formula is integration of du a square minus u square is 1 over 2a natural logarithm of, in natural logarithm absolute value, a plus u divided by a minus u plus c. So that is the formula we are going to use. In our case, a square is equal to 32 and u, yeah, a square is equal to 32. A is square root of 32. Okay. So 1 over square root of k du integration du 32 minus u square is equal to 1 divided by 2 square root of 32. And then there is a square root of k in the denominator 2 natural logarithm of a plus u. Remember our a is square root of 32 and u is square root of kv. So square root of 32 plus square root of kv divided by square root of 32 minus square root of kv is equal to minus t plus c. Okay, minus t plus c. Okay, because we have on the right hand side of the equal to sign integration of dt, which is minus t plus c integration constant. Because velocity is 0 at t is equal to 0 at time equal to 0, therefore c is also equal to 0. Okay, and therefore we get 1 over 2 square root of 32k times ln square root of 32 plus square root of k times v divided by square root of 32 minus square root of k times v is equal to minus t. Okay, is equal to minus t. Basically we proved that c is equal to 0. The constant of integration is 0. And now we will use we will multiply by 2 square root of 32 on both sides, and we will get ln absolute value of square root of 32 plus square root of k times v is divided by square root of 32 minus square root of k times v. Absolute value is equal to minus because we are multiplying by 2 square root of 32 on both sides. So it is minus 232 square root of kt. Now, if we use the definition of logarithm, then e, which is a natural number raised to the power of minus 2 square root of 32 kt, is equal to the quantity inside the absolute value, which is square root of 32 plus square root of k times v divided by square root of 32 minus square root of k v. And we will continue with this problem in part 3. So hang in tight and please come back to watch part 3. I appreciate that. Thanks for watching. Have a nice day, and please do not forget to subscribe to my channel. I appreciate that. See you.